Welcome to today's episode. We're diving into the fascinating world of the J programming language, a powerful tool that might just change the way you think about programming. J is known for its unique syntax and array-oriented paradigm, and it was developed in 1990 as a successor to APL. Whether you're familiar with programming or just starting out, J offers a range of capabilities that can enhance your mathematical and computational skills. Let's kick things off with a brief history. J emerged as a response to APL, a language popular for its concise expressions and powerful array manipulation. What's interesting about J is that it switched from APL's custom symbol set to ASCII characters. This makes it more accessible, as it uses familiar symbols to perform complex operations. If you've ever felt overwhelmed by cryptic symbols in programming, J might be a fresh breath of air. Now, moving on to some core concepts. One of the most compelling features of J is its treatment of data. You see, in J, everything is an array. Even single numbers and characters are considered arrays at a fundamental level. This makes it incredibly flexible when it comes to manipulating data. For instance, if I have a number, I can think of it as a one-dimensional array containing just one element. This perspective allows J to handle multi-dimensional data with ease. Speaking of data, let's talk about some specific types in J. Did you know that it features specialized data types, such as sparse arrays and boxes? Sparse arrays are handy because they save space by only storing non-redundant values in a larger dataset, perfect for handling real-world data that often contains a lot of zeros. Boxes, on the other hand, provide a way to group disparate types of data in the same array, which can be useful when you need to store different kinds of elements together without sacrificing structure. To put these concepts into practice, let's discuss how you can define functions in J. Functions are called verbs, and they allow you to take inputs, which are referred to as nouns. The cool part? You can define functions explicitly in a straightforward manner. For example, using a simple line of code, you can define a function that calculates the sum of two numbers while illustrating the function's flow. It's all about making the process intuitive and dynamic. And as you're defining these functions, you may encounter terms like monadic and dyadic verbs. Monadic verbs take a single argument, while dyadic verbs take two. This distinction is vital because it helps streamline operations based on the number of inputs you have. Imagine the clarity this brings when working on mathematical computations or when you're typing complex formulas. Now let's take a moment to reflect on how powerful this approach can be. Imagine you're working with large data sets, or maybe even building sophisticated mathematical models. The ability to manipulate data effortlessly with arrays and function definitions can save you time and make your code cleaner and more effective. As we approach the end of our discussion today, let's sum up some key insights. J is a programming language that prioritizes array manipulation, offers unique data handling capabilities, and supports a functional programming style with its intuitive syntax. Its versatile nature allows you to handle everything from simple calculations to complex data models with ease. Before we wrap up, I'd love to leave you with a thought-provoking question. With the rise of languages that prioritize simplicity and efficiency, do you think programming languages like J could shape the future of how we develop algorithms and process data? Feel free to ponder this as you explore J further. Thank you for joining me today on this journey through the J programming language. Don't forget to subscribe for more insights into the ever-evolving world of programming. Until next time, keep coding and stay curious.